Welcome back to the Obby series. In today's episode, we're going to be setting up the effect service. And we'll use the effect service to specify which parts will do things like damage the player, or even make them respawn when they touch a part that they shouldn't have. Now, I forgot to say this on the last episode, but before we get too deep into this one, if you do enjoy the video, or you have enjoyed the past ones, please go down below and make sure you smash the like button. And also, if you'd like to support me and gain access to all the scripts and the game file that we create during this episode, as well as a ton of other assets that you can use to easily create your next Roblox game, feel free to go down below in the description and visit my Patreon or MonzterDev, which is my own website, and you can gain access to all of those things while also supporting me as well. And with all that being said, let's hop right into Studio. Now that we're inside of Roblox Studio, the first thing that I would like to do is go over how I have our obstacles actually set up. Now, we already have gone over this in the previous episode, so I'm going to quickly touch on some of these things. If we look inside of the workspace, we have a folder called Stages, and inside of that folder is a bunch of other folders which are numbered with the specific stage that they contain the contents of. If we look inside of the first Stages folder, we can see that this contains a spawn location, a checkpoint, which every single stage folder does contain. So if we look at 10, for example, that also contains a spawn location and a checkpoint. But the folder might include some other things as well. So inside of the first obstacle, we have a couple of parts inside of here which are all named jump. But if we take a look at number 10, for example, we can see that this folder contains a couple of jump parts, but it also contains a couple of parts named kill as well. And let's actually hit the F key so that we can focus on them and see exactly where they're at. So we can see this is stage number 10. And we can also see what the kill parts actually are as well. So the kill parts are these little red circles on top of our jump parts, which are the purple/pink circles. Now, if you're unfamiliar with the Obby genre, how Obbies generally work is they will have kill parts or parts that players can touch, which will kill the player and make them respawn at their last respawn location. And it's pretty common for these kill parts to actually just be a red part. And generally, when players see red parts inside of Obbies, of course it depends on where they're actually placed at, but those parts will generally be avoided by players because they usually associate the color red with death or an obstacle to actually avoid, otherwise they will take damage or be killed. So I made it very clear here which parts I intend to be kill parts, which of course is by the name. So when we go to create the effect service, which will apply a specific effect to any effect part, one of our effects will actually be a kill effect. And I don't think I need to explain what a kill effect would be, but if you're not following along, when a player touches a kill part, we want that player to respawn at their previous checkpoint. Now, killing a player isn't the only effect that we're going to create. Another effect that we can easily create is actually damaging the player or reducing their health if they touch a part that we actually want them to avoid, rather than just flat out killing them. Let's actually take a look at some obstacles which are a little bit closer to our first stage. So if we look to the right of our first stage, we can actually assume that we have some kill parts right over here. And this would actually be stage 4, so we can take a look inside of here and see what those parts are, and we can see that those parts are clearly named kill. So how we originally intended for this to be is whenever the players touch these parts, they will flat out be killed. Now if we select all the kill parts, we can clearly see that there are the red parts right above our jump parts. So these are set up exactly the same as how we set up the kill parts for stage 10 as well. Now let's take a look at stage 5. Inside of the stage 5 folder, we can see all the parts inside of here are named jump. What we're going to do is modify the 2 red parts inside of here and actually make them become damage parts. So what I want to do is find each of the red parts inside of here, and then I'm going to go ahead and rename them to be called damage. So I've renamed the first one, and then I'll go ahead and rename the second one. Now that we've renamed those parts, this allows us to use the part's name while scripting to determine if the part is a damage part and if the player should receive damage when they touch this part. But we want to be a little bit more specific though, and with some damage parts, we would like those parts to do more damage than we might want other damage parts to do. So let's actually specify the amount of damage that we want this damage part, this first damage part, this is the one that I have selected right here. Let's specify the amount of damage that we want this part to do. So what I'm going to do is I'm going to scroll all the way down in the properties of this part, and I'm going to add a brand new attribute to this. The type of attribute is going to be a number, and the name of the attribute is going to be called damage, and make sure that you have the capitalization the exact same way, or if you use lowercase instead, make sure you remember to do this when we get around to scripting this. So now that I've added that attribute to this part, the next thing that I want to do is update the value of this attribute, which defaults to 0, and set it to a different number for how much damage I want to apply to the player when they touch this part. I'm going to go ahead and set this to 10 because I just want to slightly damage the player by just a little bit whenever they touch this part, and I don't want to damage them too much. Now, of course, we can look further and we can see that we have another damage part inside of here that we just set up, but we haven't added an attribute to this yet. And we're actually going to avoid adding an attribute to this because I would like to use this as another lesson to teach you guys. And that would be that even though we haven't specified a damage attribute on this part, we still know that we want this part to actually damage the player. And since we haven't specified the amount of damage, what we're actually going to do is set a default damage damage amount. So any part that we create inside of our workspace, which is named damage but doesn't have an attribute specifying the amount of damage it affects the player by, they'll all fall back to the default damage value, which we'll set up in our script. Maybe we'll set that number to 20, maybe we'll set that to 50, or we could set it to something higher or lower. It really all depends on whatever you want, but I think it's a good lesson to show you that we can create a default value for these parts to fall back on, or we can specify the amount of damage that we actually want them to do, like we did here using an attribute. Now, I've set up most of these parts already for you. So if we look inside of the workspace and we search for the word kill, we can see all of the different kill parts that we actually have in the Obby currently. And I didn't set up any damage parts, so the only damage parts that we have set up are currently the ones that we actually just set up right now. So now that we have a better understanding of how these different parts are going to be set up, let's actually go ahead and set up another kill part. And we're actually going to kind of use this part as a net to catch players whenever they miss a jump on an obstacle and begin falling down. We'll actually use this part and we're going to make it invisible so that the players don't see it, but we'll use it to kill those players and force them to respawn as soon as they touch it. And the reason that we're doing this is because we can have multiple stories on our obby, and let's say that the player reaches stage 20 and they're all the way up here. When they fall down from up here, they could go all the way down here and even land on another stage. So that would force the player to open up the menu, click the respawn button, or jump further off here so that they actually fall through the world, and then they would be respawned back up here. That's a pretty inconvenient experience, and we can make it a lot better. So what we're going to do is we're going to basically make one big part and we're going to stretch it out to be the entire width and length of each stage floor. And again, we're going to use that as sort of a net to catch players whenever they fail an obstacle, to quickly and easily catch them and make them respawn at their last obstacle. So we're going to create a folder inside of the workspace and we're going to rename this to be called nets. Then inside of here, let's go ahead and create a part. And I'm going to go ahead and rename this to be called first. Then let's hit the F key so that we can focus on it and see where it's at. And then let's go ahead and adjust the size property of this. Now on the X, I'm going to set that to 9,999. On the Y, we'll set that to 1, and on the Z, we'll set that to 9,999 as well. Now, once we hit enter, we can see that the part has been resized, and the size has also been adjusted as well, because the maximum size that a part can actually reach on each axis is 2,048. So that's why the size was adjusted like that. Now that we've made it a lot larger, we can go ahead and resize this if we want. If you have stages which are higher up, you want to make sure that this is wide enough to encapsulate all of those, just in case the player tries to jump as far and as fast as they can, and somehow they actually jump outside of the border. So technically, it would be fine to leave it at 2048 on both the X and the Z axis. But I'm just making some micro optimizations, which realistically are unnecessary, but we're just going to do it anyway. So that's why I'm decreasing the size a little bit. Like I said, that we could just leave it at the maximum size and we really wouldn't have to worry about it. But anyway, I'm going to go ahead and resize this a little bit, still giving it a little bit of room around each of the edges. And there we go. We have a pretty good border set up. Next, what we want to do is make sure that it's pretty good on the y-axis. So we want to make sure that this floor is not higher or touching any of the stages, because we don't want the player to be playing the obby as usual, just kind of walking through the stages as it's intended, and then out of nowhere, they just get killed instantly because this part's clipping through, or we made it too tall, or anything else like that. Our Y position is set to 0.5, so if you're curious about that, you can definitely go ahead and change it. Then what we're going to do is set the transparency of this to 1, so that we no longer see it. In addition to that, we want to set the can collide property to false, which technically this doesn't really matter, because whenever the player touches it, they should just be instantly respawned. If they are lagging or something, there is a possibility where they could touch the part, and then if it was collidable, they could stand on it for a second, and it might kind of ruin the immersion a little bit, but either way, I don't think it's a big deal at all or anything to really stress about. We do want to make sure that we have the can touch property set to true though, which it is by default, because we do want to listen for when this is touched by another player. Now, considering we've made this part completely invisible, we don't have to adjust the cast shadow property, but I'm going to go ahead and still set that to false because we wouldn't want this to cast a shadow even if it was visible. Now, we have one last thing that we want to do here, and that's actually setting the damage attribute on this part so that we can instantly kill the player. Now, of course, alternatively, what we could also do is rename this part to be called kill. And then whenever they touch this part, they would also be killed as well. But I'm trying to show you all of the different ways that you can set these different parts up to work with our effects service. Now, when we set all of our damage parts up previously, we actually named those parts damage. But here, I'm going to show you how you don't need to name your part damage. Instead, you could just set the damage attribute to it, and that will also become a damage part as well. So once we have our part selected, scroll all the way down to the bottom of its properties, and we'll add a brand new attribute to this, which is going to be called damage. And that's going to be a number. And now, what do we want to set the damage amount to? Well, we're going to go ahead and set this to 100. That's because the maximum HP that players can have in our game or on Roblox by default is 100. But of course, if you want to be safe, you can set it to something like 999, or if you plan to make adjustments to your health and you just want to make it extremely high, you can also do that as well. And alternatively, if you don't care to learn this lesson, you could even just rename this part to kill as well, and we'll accomplish all the same things no matter which method you actually choose. I'm just trying to show you how you can do this with a bunch of different methods. So I'm going to go ahead and leave the damage value set to 999 because that's perfectly fine. And with that being said, let's go ahead and set up one more net. So we'll go ahead and duplicate this part by selecting it and hitting Control-D. Then we'll bring it up a little bit, and now I want to position this just below our other stage right up here. Now, it's probably a good idea to set the transparency of this to 0 so that we can actually see it and have a much easier time moving it around. And there we go. Now I moved it down just a little bit, and that's looking pretty good. We can also look down to see if it interferes with any of the obstacles down here, and it definitely doesn't. So that's looking good, and we can go ahead and set the transparency of this back to 1. Let's then go ahead and rename this part to be called second. And there we go. We've got both of our nets actually set up. Now, another thing we need to make sure that we do with both of our net parts that I almost forgot to do is actually make sure that we set the anchored property to true so that these stay exactly in place whenever we start up our game and they don't fall down or move at all. Now, before we get into scripting, there's one more thing that I want to do, and that is change one property of a specific service. If we select the player service and scroll down a little bit, we can see just a couple of different properties that we actually can even customize here. And the property that I want to take a look at is actually the respawn time property. By default, the respawn time property is set to 3. This means that once the player dies, it takes 3 seconds for their character to actually respawn. Now, considering players are going to be dying a lot and all the time in our obby, I don't think it's a great idea to have a respawn cooldown of about 3 seconds. We want players to be able to instantly get back into doing the obstacle and trying to complete it. So what I'm going to do is set the value of the respawn time property to 0 so that the player instantly respawns and they don't have any delay and they can get right back into trying to complete the obstacle. And with that being said, we can now get into scripting. So in order to begin scripting this, we're going to go inside of the server script service, inside of the services folder, and we're going to create a brand new module script. And we'll go ahead and rename this module script to be called effects service. Then, of course, we'll go ahead and rename the module variable to be called shared, and we'll create a local variable inside of here as well, which will be called local, and that'll be set to a table. Now, the first thing that we want to do inside of the script is get a few services. More specifically, we want to get the players and the workspace service. So let's go ahead and create a variable for both of those. And of course, how do we get those services? Well, we say game. Then we use the get service method and we look for the player service. We can do the exact same thing for the workspace service, so we'll go ahead and replace the word players with workspace just like that. Now that we've gotten both of those services, we also need to require one of our own custom-made services from inside of the server script service, and that service is the player data service. So let's go ahead and create a variable for that. Now, how do we get the player data service? Well, we need to use require because it is a module script, and then we can actually just say script.parent, which takes us to the services folder because the effects service is inside of the services folder. So the services folder is the parent of the script, and then we can go right inside of the parent and get the player data service module script just like that. Now, the next thing that we're going to do is go ahead and create a type. We're going to call this type part effect, and we want to create a string union of all the different names of our effects. Now, you should know what a string union is considering we've used it before, but if you forgot, just think of a union as sort of a collection or a group of things. So to begin creating this, let's go ahead and create a string and define our first part effect. And the first part effect that we'll go with is going to be kill. Now, since this is a union and not something like a table, we need to use the pipe symbol instead of, say, a comma to indicate that we want to add another string to this. Now, what's going to be the name of our next effect? Well, we'll go ahead and say death. And now we didn't actually create or name any parts death, we named all of them kill. But I'm adding this here because in case you want to use multiple names for the exact same effect, we can easily do that as well. So with that being said, if you wanted to name some parts that are called kill, death instead of kill, you can name them death or kill and they'll do the exact same thing. We'll then use the pipe symbol again to add our third and final part effect, which is going to be called damage. Now that we've created that type, we also want to create a variable that holds all of these different effects as well. Now, this is going to be a constant variable because we're never going to add or remove anything from this table. So we want to type the name of this variable in all capital letters, and we're actually going to call this variable part_effects, and that's going to be equal to a table. And like I said, inside of this table, we want to add all of those strings to inside of here to create an array. So we'll go ahead and say kill, then we'll say death, and finally we'll go ahead and say damage. Now, thinking a little further ahead, we're going to create another variable, and this variable is going to be called player debounce. and it's going to be set to a table. Now, when we use the word debounce, we can also think of this word as cooldown. And you know what? Why don't we go ahead and actually rename this variable to be called player cooldown instead of player debounce, just to prevent any possible confusion. Now, what we're actually going to use this variable for is actually for the damage effect. Now, when are we going to use a damage effect? Well, whenever a player touches a part which is named damage or has a damage attribute attached to it, and we want to damage a player by a specific amount whenever they're touching that part. The thing is though, is that when a player's character actually touches a part, first of all, multiple parts of the character can touch that one part pretty much at the exact same time. For instance, players generally have 2 feet. So if both of those feet touch the exact same part, then we would damage the player twice because 2 of the parts from that player have triggered the damaged part to actually be activated. And now, in reality, we most likely wouldn't want that to actually happen. We most likely would rather intend for the player to be damaged a single time when they touch the part, rather than being damaged multiple times depending on how many of the parts from their character actually touched the damaged part. So, whenever a player touches a damaged part, we're going to add them to this table and give them a very small cooldown. And by very small, I mean less than a second. It's just enough to prevent the player from getting continuously damaged or receive damage multiple times just because they touched the part with multiple parts when we intended to only count for 1. So now that we've created those variables, let's go ahead and start creating some functions. Now, the first function that we're going to create is going to be a part of the local table, and we're going to call this getEffect. The first parameter is going to be a part, which is going to be a base part. Now, if you're unfamiliar with the type of a base part, basically it is the primary part that all other parts actually extend from. So the actual part type extends from a base part. The mesh part type also extends from the base part as well. So all of these different parts extend or originate from the base part. So technically, if we were to pass a mesh part or a base part through to this function, those would all be completely fine because we're handling that part as if it was just a basic base part. And now we want to set the return type of this function to the type that we created earlier, which is the part effect type. But the thing is that the part that we pass through to this function might not always have an effect. So because this function cannot guarantee that we'll always return an effect, we're going to include a question mark here to indicate that we may not always get an effect from the part that was given to us. So don't always expect that when we use this function. Now that we've done that, we can hit the enter key and the end statement should be automatically created for this function. And if you see that the end statement is underlined in red, that is because we did not fulfill the actual return type of this function. So the red underline will go away when we actually set up our return statements. Anyways, with all that being said, the first thing that we're going to do inside of here is create a variable called effect. And we're going to set the type of this to part effect. Now, by default, we're not going to set this to anything. We'll go ahead and set that in a little bit when we actually determine what type of effect we can get from this part, if it even has any. Now, let's consider how we can determine the effect that a part actually has. Well, currently, there's 2 different ways that we can determine this. 1, by the name of the part, or 2, by the attribute of a part, more specifically, if the part has an attribute which is called damage. So let's go ahead and get the damage part first, based on if the part contains an attribute called damage. So we'll create a variable called isDamageEffect. And how are we going to determine this? Well, we're going to use the part, and we're going to use a method on it called getAttribute. This, of course, will return to us the value of the attribute if the part has an attribute with this specific name. So we want to pass through a string to this method, and that string is the attribute that we're looking for, which is going to be called damage. Now, of course, make sure you spell that correctly and you use the exact same capitalization that you used when you set the damage attribute on whatever parts you may have set it on. If you used a lowercase when you set the attribute, then make sure you use a lowercase d here as well. Just make sure that you have the capitalization and spelling correctly, otherwise, of course, you're going to run into issues. So now that we're getting the damage effect from the attribute, let's also create a variable so that we can get the effect from the name as well. So we're going to create a variable called effect from name. And now, how can we easily determine the effect from the name of the part? Well, what we're actually going to do is use the table library, and we're going to use a function called find. Now, for the first argument of this function, what we need to pass through is the table that we want to look through. And the table that we want to look through is the part effects table. Then, for the second argument, we want to pass through the string that we want to look for inside of this table. And what do we want to look for inside of this table? Well, we want to check if the name of the part actually exists inside of our part effects table. Now, what does the find function actually return? It doesn't really matter, but it actually returns to us a number, and that number would be the position in the array where the string was found. So let's say for instance that the part was named death. When we look inside of the part effects table, the number that would be returned from this function would actually be 2 because death is the second stored value inside of this table. Again, like I said, the number that's returned here doesn't actually matter, but I did want to fill you in on what the return type would be from this function. So if we do actually get an effect from the name, this variable would be set to a number. So now that we've handled both ways for getting the effect from a specific part, we can then use some if statements and then set the effect variable before we return it back to wherever this function is called from. So first we can go ahead and check if we got the damage effect from the attribute. So if isDamage effect is true, then what we would do is set the effect variable to damage. Then we can use an else if statement, and then we can check if effect from name is actually set or has a value. Like I said, we don't actually care about the value of this. More specifically, we don't care about the number that this could possibly be. We just care that this value is actually set, because if we're not able to find anything inside of this table, then effect from name will not be set to anything. It'll instead be nil. That's why we're just using an else if statement here and just checking if the value has actually been set and is not nil. So now that we know that we've gotten the effect from the name, let's go ahead and set the effect variable to the part.name, and then we can cast that to the part effect type, because that is what it actually would be. Now, although like I said, we don't actually care about the number that's returned from find, I would like to show you how we could instead use the number that's given to us from that to actually get the effect as well instead of using part.name. So since table.find returns to us the position of where this effect is actually stored, if it's stored or found inside of this table, we can actually use that information to get the specific string from this table. So since we know that we've gotten the effect from name, what we could do is use the part effects table and index this with the number that is returned to us from table.find. So we can simply just index this with effect from name, and that would set the effect variable to whatever effect has actually been found from the name. So either of those two methods would work perfectly fine that I showed you here. Anyways, after we've actually determined the effect, the last thing that we want to do is go ahead and return whatever effect we actually found. And now that we've done that, we can see that the red underline is gone from the end statement right here, and we are all good to go with this function. Now that we've created this function, let's go ahead and create our next function, which we'll actually use for setting up all of the effect parts inside of our game. So we'll go ahead and create a function, which will be a part of the local table, and we'll call this setUpParts. Inside of this function, what we want to do is loop through all of the parts inside of our workspace. So we're going to create a variable called descendants, and that's going to be equal to workspace::get_descendants. Now, I'm pretty sure I've already explained descendants to you before, but basically, the getChildren method will return to us everything directly under the workspace service. So if we look inside of the workspace service, it would give us the camera, the terrain, the nets folder, the portals folder, the stages folder, and the readme script right here. But now, if we were to use the getDescendants method, it would return to us all of those children and everything inside of the children, and everything inside of the children, inside of their children, inside of their children, and it would just literally go all the way down until it cannot go down any further. So we would literally get everything stored inside of the workspace by using getDescendants. So now that we've gotten the descendants, let's go ahead and iterate through them. So we'll say for underscore, because we're not going to use the index, but we will use the value, and we'll call the value descendant. And we can actually cast the type of this variable to base part, which isn't technically correct because as we're iterating through all of the descendants inside of the workspace, not all of these are going to be base parts. But by casting this type, when we actually use the descendant variable, it'll make Studio's auto-completion and suggestions a lot smarter and more accurate. And before we use the variable, we will guarantee that it is actually of the base part type. So right now we're kind of preemptively lying to ourselves, but we'll make up for it and guarantee that we are actually correct. And we just kind of have to do this because Studio is a little, I don't know how you say it, not too smart in all scenarios. So yeah, anyways, now that we specified the type of the value, let's then say in, and then what do we want to iterate through? We want to iterate through the table of instances provided to us by the descendants variable. And then we'll say do, and now we're iterating through all of those descendants. So the first thing we're going to do inside of here is create a variable called isPart. Like I said, we want to verify that what we're working with is actually a base part so that we are not lying to ourselves. So how do we check if the descendant is a part? Well, we can say descendant and then use the is a method and check if it is of the base part type. And now, if isPart is not true, so we'll say if not isPart, then what we'll do is continue and then say end. So we'll continue iterating through the loop and going through each of the other descendants to check if they are parts, and then we'll do whatever we want to do with them. But of course, if it is not a part, then we do not want anything to do with it, so we'll just go ahead and continue through the iteration like we should. Now, the next thing we want to do is create a variable called effect, and this is going to be set to the effect of the part, if the part even has an effect. And how can we get the effect from the part? Well, we can use that function that we created earlier called getEffect. and all we have to do is pass through the descendant to that function. Now, similar to what we did with the isPart variable, if we do not get an effect, so if not effect, then what we want to do is continue iterating through the loop and not go any further with this specific descendant. Okay, so now that we've determined that this is actually a base part and it does actually have an effect, so technically it would be an effect part, we can then go ahead and actually start setting up the effect itself. So what we're going to do is we're going to go ahead and use the descendant variable, and we're going to go ahead and listen for it to be touched. So we can connect that event to an anonymous function, and our anonymous function is going to have one parameter, and that is going to be other part, which of course would be the other part which actually touched this descendant and caused the touched event to be fired off. So since we're given the other part, what we want to do is we want to check if the other part which touched this part actually belongs to a player. So we can create a variable called player, and now to determine if the other part belonged to a player, we can use the player service and use the getPlayerFromCharacter method, and then we'll pass through the other part.parent to that method to get the player. Now, if we're unable to get a player from that part, then we want to go ahead and stop the function right there because we don't want to do anything. But now, if we do actually get a player from the part which has touched the effect part, the next thing we want to do is check if the player is on cooldown. So we'll create a variable called isOnCooldown, and to check if the player is on cooldown, what we'll do is we'll actually index the player cooldown table with the specific player. And now, if we are able to find the player inside of the cooldown table, so if is on cooldown, then what we're going to do is actually return end and stop the function right there as well, because we don't want to affect the player if they've already been affected by this effect within the last few frames. So now we've confirmed that the player is not on cooldown, let's go ahead and actually set them to be on cooldown. To do this, what we'll do is we'll actually index the player cooldown table with the specific player, and then we'll set the value to true. Now we've added the player to the cooldown table, let's then also set up removing the player from the cooldown table as well, and we can do this by using task.delay. When we use task.delay, basically, this will allow us to run a function after a specific amount of seconds. So for the first argument, I'm going to pass through 0.1 because I want to run this function a tenth of a second later. And then for the second argument, we're going to pass through an anonymous function inside of here. And all we're going to do inside of this function is index the player cooldown table with the specific player, and we're going to set that to nil. When we set the value of a key inside of a table to nil, that will actually remove that key value pair from that table. So effectively, that removes the player from the player cooldown table. And now there's another thing with task.delay. When we use task.delay, it doesn't actually stall the function at all. So what I mean by that is when we're using task.delay, you might think that the function would pause here for a tenth of a second, but that's not actually true. Task.delay doesn't actually stall at all, and it'll basically just run whenever we specified it to run without interfering or stopping the function right there for that amount of time. So now we can do the next thing that we want to do, and that would actually be applying the effect to the player. So let's go ahead and actually create a comment here, and we're just going to say use effect because we actually haven't created the function to do this yet. But now, just to wrap up what I was trying to explain with task.delay, we're going to replace this comment with calling a function here. But I want to make it very clear that how task.delay works is this function will not be stalled when this is called. So when we use the useEffect function, that function isn't going to be called 0.1 seconds later, it will instantly be called. We can compare this to something like task.wait, and we can set this to 0.1. And now what task.wait would do is it actually would cause this function to stall for 0.1 seconds before it then goes ahead and actually uses the useEffect function. So this function will stall, but this function will not stall. So everything we put after this function will instantly happen, whereas task.wait actually stalls and will prevent any of the code running after it from happening until the time has actually been completed. Hopefully that explanation was not too hard to understand. But with that being said, let's go back towards the top of our script and actually go ahead and create another function, and we'll attach this to the shared table. This function is going to be called useEffect. And now for our first parameter, that's going to be a player, which is of the player type. The second parameter will be the actual effect, which would be of the part effect type. And the final parameter will actually be the specific part, which would be of the base part type. So now, when we want to go ahead and use the effect on a player, the first thing that we want to do is actually get their character. So we're going to create a variable called character, which is going to be equal to player.character. Now, if we do not get their character, then what we're going to do is actually stop the function right there. After we've gotten the player's character, we also want to get their humanoid, which is stored inside of the character. So we're going to create a variable called humanoid, which is going to be equal to character. Then we'll use findFirstChild of class, and we'll look for a humanoid inside of the character. And now, if we're unable to get the humanoid, then we'll go ahead and stop the function right there. And now we'll actually go about handling our specific effects. So we're going to create a variable called isKillEffect, and how we can determine if the effect is of the kill type is if the effect is either called kill or death. So we're going to say if effect equals kill or if effect equals death, then we know that it is a kill effect, and we basically want to do the same thing either way. We'll also create a variable called isDamageEffect, and how can we determine if the effect is of the damage type? Well, of course, we would say the effect would equal damage. So now, if it is a kill effect, then what do we want to do? Well, we would actually use a method of the player, and the method that we want to use is called loadCharacter. And all this method does is it literally respawns the character. So it's as simple as that. That's all that we have to do if we want to kill the player. Then we'll use an else if statement, and we'll check if it is a damage effect. Now, if it is a damage effect, the first thing we need to do is actually determine the amount of damage that the part gives off. So we'll create a variable called damage. And now to determine the damage, usually the part should have an attribute called damage set to the specific amount of damage that we want it to do. But if that's not actually the case, then we'll also say or, and now specify the default amount of damage that we want parts to do as well. And by default, I'm just going to go ahead and say that I want parts to do 25 damage. Now that we've determined the amount of damage that the part should do, let's go ahead and apply that damage to the player. Now to apply damage to a player, we actually have to use their humanoid, and we'll adjust the health property of that humanoid. So we'll go ahead and use minus subtract, and what we'll subtract from the humanoid's health is that amount of damage. And there we go. We are pretty much fully finished with creating this function, but there's one more thing that we can actually do inside of here. After we determine what effect the part should actually apply, we're going to go ahead and create a variable called deathAction, and we'll set the type of this to the player data service.updateState action type, and then we'll actually set the value of this to a table. What type of action are we going to use? Well, of course, that would be the update deaths action. Then how many deaths are we going to apply to the player? Well, we're only going to apply one death. Now that we've created that action, let's go back and look at when we actually apply these effects. When we apply the kill effect, we already know that we instantly kill the player, so we definitely want to add one death to their stats. To do this, we need to use the player data service, and we would use the update state function. We'll pass through the player, and we'll also pass through the death action as well. Now, when it comes to damaging the player, we don't always just instantly flat out kill them when we do damage to them. Instead, we need to check if the player has actually died, and if they did, then we want to go ahead and update their state with another death. So let's create a variable called isDead, and to determine if the player is dead or not, we can use the health of their humanoid and check if it is less than or equal to 0. And now if the player is dead, then what we would do is we would go ahead and do the exact same thing that we did earlier. So we'll use the player data service, we'll use the update state function, we'll pass through the player, and we'll pass through the death action as well. So if the player takes enough damage that they do actually die from the effect, then we'll go ahead and add a death to their data. And with that being said, we're fully finished with creating this function. So let's go ahead and use the useEffect function, and we can use it down below in the setupParts function. So we'll go ahead and replace this comment with shared.useEffect, we'll pass through the player, we'll pass through the effect, and finally we'll go ahead and pass through the descendant as the part. And now with that being said, we're also done with creating the setupParts function, so let's go ahead and use this as well. And when are we going to use this? Well, let's go towards the top of our script, and we'll go ahead and create our usual onStart function. Now, inside of our onStart function, we'll go ahead and call the local.setupParts function just like that. So we'll go ahead and set up all of the parts whenever our game starts up for the first time. Now, there's actually one slight change that I want to make, and that is towards the bottom of our script. Inside of the setupParts function, we want to look for where we actually implemented the logic for when the part is being touched, and after we check if the player is on cooldown or not, we then apply the cooldown here. But now the thing that we want to change here is actually the delay for when we remove the player from being on cooldown. Rather than setting this to 1/10 of a second, we're actually going to set it to 0.5, which would be half of a second. And the reason that we're doing that is because the effects that we're actually using, such as the kill, damage, or death effects, we really intend on only applying those effects to the player when they touch that part a single time. And we can actually easily see exactly why we're making this change when it actually comes to increasing the player's deaths. So when we remove the cooldown after 1/10 of a second, allowing the player to trigger this effect once again, even though we used the load character method on the player, with such a short delay, the player is occasionally able to trigger the kill effect once again, effectively increasing their amount of deaths more than once, even though they only actually died a single time. So that's why we want to remove the player's cooldown after a little bit longer, in order to prevent them from triggering the effects multiple times when we really only intend for it to be triggered a single time when they touch the part. But now, with all that being said, we are actually fully finished with implementing this script, so we can go ahead and close out of this. and then we can go into our game and actually test this out. So hopping into our game, we can actually see that I already started with 32 deaths. The reason for that is because I'm actually re-recording this part of the episode, but let's also think back to the beginning of the video where we actually made the 2 red parts of stage 5 damaging to the player. So let's go ahead and jump on this red part right here. And once we jump on it, we can actually see that we have received some damage. And now you might have noticed that we have actually taken more damage. And the reason for that is because our character automatically has some animations applied to it by Roblox. So when our character moves and kind of looks around idly, it can trigger this effect to happen once again because the player is still standing on it. And when the animation happens, the player's parts are moving around and retouching this part again, effectively activating the effect once again. So I think that's all perfectly fine and that's working as intended. But I did want to make it very clear why that's happening. Now, I'm pretty sure that part that we set up has applied 25 damage to the player, and this one should only apply 10. So yeah, we can see a lot less damage is actually being applied to the player. And now these parts right here are actually kill parts. So when we touch them, we should instantly be killed. Let's go ahead, walk over to them, and see once we touch them, we have been killed and respawned. And we can also see that another death has been applied to us as well. Let's also test out our nets. So we'll just jump off this part right here, and we should automatically be killed just like we were right there. So this is actually all working correctly. And with all that being said, that's going to be it for this episode. As always, if you did enjoy the video or did help you out, make sure you smash the like button and leave a comment down below if it worked. This will help other people know that this is not outdated and it does still actually work. And if you want to support me or gain access to all the scripts and the game file we made during this episode, as well as a ton of other resources that you can use to make your next Roblox game, feel free to go down below in the description and visit my Patreon or my own website, MonzterDev, to get access to all of those things. And with all that being said, I hope that you have a great day, and I'll see you guys in the next episode.